Today our lecture is about composite function from the front mathematics. I am Dr. Saima. The composite function. Let we have two functions f and g, and we want to take its composite. So what does the composite function mean? We are combining the two functions f and g, and composition is a binary operation on functions. So how we will combine f composition g? uh, we write x on right side. So first we apply g on x and then we apply f on g of x. So by this diagram you can see easily that on x we apply g to get gx, then we apply f on gx to get f of g of x. This is called f composition g. So to find the domain of f composition g, x which is input should be in the domain of g, so that we can apply g on x to get g of x. Now to apply f function f on g of x, g of x should be in the domain of f. So we can say the domain of f composition g, the set of all x in the domain of g, such that gx is in the domain of f. So if gx is in the domain of f, this means we can apply f on g of x and get f of g of x. Similarly, for the composite function g composition f, first we apply f on x and then we apply g on f of x. So the domain of g composition x is the set of all x in the domain of f, x in the domain of f and f of x in the domain of g. Now we do one question of exercise B, question 51 of the book Calculus by Swokowski, Olinick and Pence. It's 6th edition. The question is, if f of x is equal to x over 3x plus 2 and g of x is equal to 2 over x, find f composition g of x and domain of f composition g. Part B is find g composition f of x and its domain of g composition f. Now first I will do part 1. F composition g of x means f of g of x. First we apply g on x and we get 2 by x. Then we apply f on 2 by x. Now our input is 2 by x. So what f maps x on x over 3x plus 2. So instead of x we will write 2 by x. 2 by x over 3, 2 by x plus 2. Then we will simplify it, take LCM on denominator and we get 3 to the 6, and due to LCM we get 6 plus 2x over x. Now we can write in multiplication form 2x into the denominator will be inverted 2x over 2 into 3 over 3 plus x. Either here I take 2 common and now x will be cancelled. Now x will be cancelled and 2 will also cancel and we will get 1 over x 3 plus x or 1 over x plus 3. Now to find the domain of f composition g, first we find the domain of g, which is the first function applying on x. So domain of g is you can see g is a rational function whose denominator is x, but x can't be 0. So domain of g is r minus 0, the set of real numbers minus 0. Now the domain of f of g of x, which is 1 over x plus 3, is x plus 3 x plus 3 can't be 0 because it is in denominator. So this means x can't be minus 3. So domain of f of g of x is r minus minus 3. So all real numbers except minus 3. So domain of f composition G is x belongs to, first x belongs to domain of G. So domain of G, and then Gx belongs to domain of f. So when Gx belongs to domain of f, then we can apply f on G of x and we get f of G of x. So intersection domain of f of G of x. So domain of G is r minus 0, intersection domain of f of G of x is r minus minus 3. So we take its intersection and we get r minus minus 3 and 0. All real numbers except minus 3 and 0. So how we get this formula from the definition, and it says that x belongs to G, domain of G. So we write domain of G. So the first function on which x apply, and then Gx belongs to domain of x. When Gx belongs to domain of f, then we apply f on G of x and we get f of G of x. So the other domain is domain of f of G of x. We take its intersection. Here in domain of G, all real numbers except 0, and in domain of f of G of x, all real numbers except minus 3. So 0 and minus 3 are not common, not in both sets. That's why we remove them, and the domain of f composition G is r minus minus 3 0, means all real numbers except minus 3 and 0. Similarly, the part B is find G composition f of x and its domain. G composition f of x, first we apply f and then we will apply G. So f of x gives x over 3x plus 2, and now this is input function and we apply G on it. So instead of x we write x over 3x plus 2. Then we simplify it. We take 3x plus 2 goes up and it becomes 6x plus 4 after multiplying by 2, 6x plus 4 by x. Now the first function is, first we apply f. So we find domain of f. Domain of f is x over 3x plus 2. So in the denominator we get 3x plus 2. So then 3x plus 2 can't be 0. So this means that x can't be minus 2 by 3. So domain of f is all real numbers except minus 2 by 3. And g of f of x is 6x plus 4 over x. It is also a rational function and x can't be 0. So domain of g of f of x is r minus 0. Now domain of g composition f is first function which apply on x, that is domain of f, intersection domain of g of f of x. So we put its values. Here intersection we take r minus minus 2 by 3, all real numbers except minus 2 by 3 and all real numbers except 0. So we exclude these points and the domain of G composition f is all real numbers except minus 2 by 3 and 0. I hope you understand composite function, and by these useful formula you can now easily find the domain of composite functions.